So, yes, my name is James Titcumb. I've been a PHP developer since about 2002-ish, and programming since before that. I'm a bit of an open source fanatic whenever I have time to do things, this elusive time thing. I'm also available to hire through these people called Rove. We're a purveyor of fine elephants, which I will give one of our Rove elephants away at the end of the talk, and I also have my last Heroku goodie bag, which someone can claim by asking a great question or something like that. Rove are a group of freelancers. We're committed to making high quality software, and we do quite a lot of project rescues and things like that. You can find me on Twitter, on Mastodon, at Asgrim, as Susanna said. And you can also join our new Rove Discord server, where you can come and chat with us and friends, talk about gaming, tech, whatever. Occasionally get some free advice, because otherwise we usually charge, you know. So, but yeah, feel free to come and join the Discord. We did have like a social last night, which was kind of fun. Went out for pizza with a load of Discord members. So yeah, if you want to get involved, the link is on the screen. Yes, I planned that slide well. Yes. Okay, now onto the talk. Okay, so situations where this talk might be useful, right? I'm thinking of things like a rushed startup where you've cut some corners, maybe you don't have such a great CI pipeline, something like that. Or maybe you've just got an existing code base that's going on for quite some years and you want to give it some attention, make it work a bit better. I hasten to use the word legacy. If you saw my talk last year, then I don't like using that term very much. But yeah, or maybe you've got some really basic pipelines, they don't really do much, and you want to find out a bit more about it. That's why you're here, right? Actually, you're here because it's a single track, so you have to watch me, but sorry. So just to give you a heads up, there is some opinionatedness, not necessarily just from me, but also from tools and so on, which we'll talk about in a bit. And I'm not just talking like tabs and spaces and so on, but strictly speaking, that stuff doesn't matter. But what I would say is that when we're talking about quality and things like that, we need to go big or go home, right? Being strict on everything is a real change of mindset, rather than just being like, oh yeah, that's good enough, ship it. It's almost like a discipline we've got to get into. You don't compromise on quality, you don't cut corners, always. When you do cut corners, you are aware of what you're doing and why you're doing it, and taking that into account when you're making the decision to cut those corners. So, you come to a point where your feature or bug fix is ready to push to your remote, and you start going through your mental checklist, right? You start saying, oh, have I run the test? Okay, run the test, blah, blah, blah. Have you checked the dependencies that aren't broken for whatever reason? Have you run the mutation tests? I'm definitely going to trip over that eventually. Yes. There's a lot to remember, right? You're going through this list and you're like, you've got to ask yourself one question. Do you remember them all every time? Well, do you, punk? So what is CI, right? What is continuous integration? I mean, in essence, it's really just a tool to automate execution of tasks, right? Such as running tests, checking your coding standards, and so on. CI means you don't have to remember to do lots of these things, which is nice, right? For example, you work on your change, you locally run whatever tests necessary for your feature itself. The tests pass, that's great. But you don't want to run every single test suite every time, right? So you push it to CI. You let it run the whole test suite, because it's a lot cheaper to run a machine to do this stuff than it is to pay all of us folks, right? It saves money. And this helps you to identify unintentional regressions elsewhere that you're not focused on, right? You make a change and inadvertently breaks something elsewhere. You're like, what? How did that break? Well, it did. And now you've got to figure out why. So it's about building a safety net, right, to a degree. You can reduce your fear of breaking something, right? And I say reduce, right? You're not eliminating the risk of breaking. This is not like you have CI and everything will be amazing. No, you're reducing your risk. You're doing what you can to mitigate risk. So the goal in very simple terms is like, if it says it's red, if there's a red cross by it, it's not ready. If there is a green tick, it's ready to be reviewed, right? Who's used Jenkins before? Hands? Quite a few, all right. Has anyone ever set up Jenkins from default and noticed the status icons are actually blue by default when it's green? Anyone know what that is? Kieran? That's apparently not true. What? Apparently it's to do with Japanese cultural influence from the creator of Jenkins, and apparently traffic lights in Japan, I've not been to Japan, I don't know, are like a slightly bluish tinge. So apparently that's where they came from. Anyway, slight digression there. So why do we want to do this? Well, like I said, so we don't have to remember to run all the tests, and we get a machine to do these things for us, so we don't have to do it all the time. We can spend our time watching YouTube videos or reading Mastodon posts or Twitter posts, whatever. Wait, hang on. No, do something productive. So let's lay some groundwork. Dig some foundations. So we'll start with Composer, right? Composer is not strictly necessary in a PHP project, right? And I think probably the majority of people, don't worry, I won't ask you to put your hands up again. I think the majority of people here will be using Composer. And it may surprise some of you that not every project still has jumped on the Composer bandwagon. And that's okay, right? This stuff still works, right? We don't have to be adopting things that are life-changing. Maybe missing out, but whatever. Yeah, so I'm kind of assuming that we're using Composer to install all of this stuff, all our tools and so on. And we start with a very useful tool, a unit testing tool, PHP unit, you may have heard of it. And so we have to actually start off with having some tests, right? So here's a couple of quick tips about getting started for testing, because that's kind of necessary if you want to have a CI pipeline that checks stuff. Ultimately, good tests are better than bad tests, and bad tests are better than no tests at all. So how do we get there? Well, just start with something, right? A lot of people are like, oh, you have to write your tests in this particular way, and it has to not be brittle, and you have to like mark or not mark or whatever. Don't worry about it. Just stop stressing about it. Go and write a test, right? Just go through, execute some code, make it pass. You've written a first test. That's great. That's a good starting point, right? When I first started writing tests, I'm sure they were terrible, right? And that's what it is. It's a learning journey, okay? So don't like get bogged down with like, oh, it's got to be right. Don't worry about it. Just get something done, right? Just get like a very simple, single happy path part of your application that is, relatively straightforward to test. Hopefully some kind of key functionality that will give you a bit of confidence that, okay, we're not going to break that thing from now on. And once we've got to a more comfortable level of tests, like, okay, we've got like, 100 tests or whatever eventually, that's fine. We can go back and review the tests and say, are they still producing value, right? Are they brittle, right? Do they keep failing? We have to keep going and saying, oh, this one keeps failing because every time we run it, we have to put a new number in or something, I don't know. But that's okay. You can replace or delete them and so on, right? Once you've got that confidence to a certain level, then you can reevaluate, where are we now? We're somewhere at least, right? So just start writing tests, but The most important thing is to build a good testing habit, right? So, and this is what I mean earlier by saying, like, you've got to be strict on things and make sure that you're like really like on it all the time and saying, okay, we need to make things better. This is one of those things, right? We have to say, okay, every change we make, every merge request, pull request, whatever tool you're using, every change gets reviewed, right? Every change gets tests with it, right? So if you have a bug fix, you have a test to make sure that the bug doesn't reoccur. If you make a new feature, that feature should come with tests to prove that the feature works, right? And you don't have to go back and write tests for everything because, you know, depending on the size of your application, it might take ages. It might be completely fruitless, you know? Testing key bits, that's fine, whatever. And you also need to empower your reviewers, like the people reviewing the code, to say, like, this change doesn't have any tests, so we can't merge it yet. There are always, like, exceptions to this, though, okay? There's no rules in this game, right? Everyone says, oh, this is the best way to do things, but there are always, like, exceptions to those rules. And for example, like, if your production environment's on fire, maybe not literally, then you want to ship the fix, and that's fine. But ship the tests after as well. Like, once you've done a like retrospective or, you know, analysis of what went wrong and so on, have the tests, write the tests to follow up and make sure that that thing doesn't happen again. So it's got to become a habit if you're not already in that habit. So the next tool is something like coding standards tools, right? There's PHP Code Sniffer, PHP CS Fixer, and so on. They're all fine tools, right? These, I really hope these days are kind of a no-brainer. You just set one up, pick a coding standards, and be done with it, right? And this is what I mean earlier. Tabs and spaces, I don't care, because the tool does it all for me. I just run the tool, and it says PHP CBF or whatever you're using, and it fixes all those issues, and I don't have to think about it. Very, very occasionally, there's something you have to manually fix. So, you know, start with something basic, straightforward, like PSR12. That's got some, you know, basics coding standards. That's fine. If you want something a bit more comprehensive, as Claudia said, Doctrine is not just the ORM. They also have got Doctrine coding standards. You could use that, and that's really comprehensive. They took in another library called Slevermat coding standards, and that has like a whole load of stuff. But yeah, just be done with it. And then there's SARM and PHP Stan and tools like this, right? Static analysis tool. My advice with these tools, if you're not using them yet, is always set it to the strictest mode you're comfortable with, which is hopefully the strictest mode. And just roll with it, right? Use a baseline, right? You say, okay, we'll come back to that, right? So what are these tools? They are tools that analyze your code statically. Again, we'll come back to that in a moment. It determines the types of things that are going on in your code and tells you if they're right or wrong and when you're passing when. Magically works. But yeah, setting up a tool like SARM, PHP Stan, set it on the strictest mode, create a baseline, and the baseline allows you to basically say, okay, all of the stuff that we've done wrong so far, we'll put that into the baseline, and the baseline says, okay, anything that's there, we won't tell you about that for now. But the advantage of doing that is that all the new code that you write, you add, or the code that you change to introduce new issues, those new issues will be saying, oh, you are doing this mixed type wrong, okay? So go and fix that, right? And it will suddenly like make you think a whole lot differently about how your code is running, because it will keep telling you you're doing things wrong all the time. And it's quite often right, and it quite often finds bugs, right? So yes. Sometimes, especially when you're working on a large, older code base, when you do some refactoring, you'll suddenly introduce a whole load of new issues, rather. Like for example, if you change a class, refactor it a lot, the baseline will suddenly start saying, oh no, you got a load of new issues, or actually they were already there. Or if you define a type better and start playing what I like to call static analysis whack-a-mole, which is where you define a type better, and then everything that was using that type is suddenly like, oh, now I'm wrong too. And so you have to go back and fix all of these things. And then somewhere else, like, is this cascading effect. And I can see the nodding people. They're the ones that are using static analysis already, and they know exactly what I mean. So yes, baseline, use it. There is something about static analysis, though, that is quite interesting. And the key is in the word static, right? It is analysis of the code without executing it, right? Most of us have probably heard about reflection. Reflection in PHP, you have to have the code loaded, right? So in a sense, you've loaded that code in, not necessarily executed it, but PHP has an awareness of this code, right? It knows what this code looks like. Static analysis is different, right? It's looking from the outside in, and it's analyzing the code without executing it, without loading it into PHP itself. And it's critical to understanding tools like PHPstand and some. And the important thing to remember is if a tool ever executes code, it no longer is static analysis because it's running the code. I've seen some plugins for like static analyzers which execute the code. I'm like, okay, you've defeated the point of the tool, but hey. Very often SARM is just, in PHPstand, you know, you add it, compose or require, --dev, something like that. But you don't necessarily have to do this. And there's a very helpful use case on older projects, on old PHP versions. So I am working on a project that uses PHP 5.5. And I would like to use SARM, which doesn't work on PHP 5.5. But the benefit of it being a static analysis tool is that we don't have to include it in this project, so we don't. Instead, what we do is we have another folder, which is essentially a separate sub-project here, which uses PHP 7.4. You might ask, well, why not PHP 8, James? That's the newest and greatest. Well, actually, due to the ancientness of PHP 5.5 source code that we have, SARM under PHP 7.4 was the newest we could get because it started crashing when we upgraded it to 8. So, well, luckily the newest version of SARM works in this case on PHP 7.4, so we're all right for now. We don't have to worry too much. But we run this tool instead of like as part of the application. We run it in a separate Docker container which runs PHP 7.4, so we can use the new tools on the old ancient code base, right? And all because this tool, SARM, does not run the code. It statically analyzes it. It just looks from the outside in. If you think about it, a tool like SARM or PHPstand could be written in any language. It doesn't have to be written in PHP. They are, but it doesn't have to be. You could write a static analyzer for PHP in Rust or C or whatever. The world's your oyster, right? Because it doesn't load the code. It just looks at the code and says, you're wrong. So, we digress slightly. Let's go to the pipeline. So, GitLab pipelines, GitHub actions, all these kind of things, they're very useful, right? Ultimately, all of this stuff is just a really fancy way of running shell commands. That's all CI is, right? Quite often it's like wrapped up in nice Docker images or, you know, even if you're not aware of it, half of this stuff does run under Docker. But yeah, it's just running a load of bash scripts. Woo! So if you break it down like that and just say, okay, I'm just running a script, it's much easier to understand what's going on. All the other stuff just makes it nicer, right? And these things allow you to test things in Windows, Linux, OS X, whatever you like. So a CI pipeline is triggered by things, right? And that's going to be things like you make your commit, and then you push it to the remote, right? That is one kind of trigger, usually called a push, funnily enough. There are other triggers, like a pull request, or pull request target is a special one on GitHub Actions. So these triggers are things that start the pipeline off, right? And it's not just for code changes, there could be tags. Like Andre this morning was like, oh yeah, I have all these pipelines that do all these things. That's a perfect example. Like you tag something and then it just, a whole load of other stuff happens. There's a tool called Laminus Automatic Releases, which I roll out to everything I possibly can, because like you close a milestone on GitHub and then it releases your code for you magically. And it makes a new branch, a new release branch and all that, and I don't have to worry about all this stuff. This is kind of the point, isn't it? We want to remove all this pain from ourselves. There are other ways of triggering it, like manual jobs, like you want to run something when someone clicks a button. Like maybe you need some kind of manual approval process for deployments. Scheduled jobs, like, oh, I want to run this every day at like 9 a.m. or whatever, just when I'm coming to the office. Or every week or every month or whatever, just to have like some kind of maintenance, right? So I maintain a library, which is an APM, and it has compatibility with like Laravel Symfony and things like that. And new releases of these things happen. So I have a scheduled job that runs every week to make sure that like any new releases of these other frameworks have not broken my library, right? So I use scheduled jobs for that. So, GitHub Actions. I'm just picking on this for an example, really. The pipeline here will do something like check out the code. If you use GitLab pipelines, it does that automatically. It doesn't have a distinct step as such. You install some dependencies. Sorry, you install PHP first. You may have heard of that if you already use some basic GitHub Actions. Run composer install. You run your PHP unit, you run your SARM or PHPstan, you run PHPCS or PHPCS fixer, and that's it. That's the minimum viable pipeline, right? But why? Well, you now have this minimum level of confidence, right? All the stuff that you've written tests for so far, they won't break anymore because the build will fail. The build will go red, and it will say, hi, I'm broken. And so you're not going to merge that code until it's made the build go green, right? Because we're going to now be really strict about, we only want green builds from now on. SARM will tell you if you introduce a new static analysis issue. PHPCS will tell you if you used a tab instead of a space. It tells you, it gives you that feedback. So a bit about code reviews. Code reviews are interesting. They're opinionated, right? Because they're done by humans, and humans are usually opinionated. But actually, funnily enough, so are most of the tools. And I know Andre said this morning, like the base of PHPstan, he tries to keep it unopinionated. But I would say, okay, we'll install the strict ones that are opinionated as well, right? Because there's a reason for these things, right? But the nice thing is, using an opinionated tool means that we as devs, when we make a mistake and the tool shouts at us, we can be angry at the tool instead of our colleagues. Because we don't want to be angry at our colleagues. Like your colleague says, oh, I really want to use tabs. And then you say, oh, I really want to use spaces. And then you start shouting at each other. And that's how your working relationship breaks down. So getting tools to do the review, or as much as the review as possible, is kind of a goal I have, right? You write the tests, so the reviewer doesn't have to look for bugs. You use coding standards so that the reviewer does not have to look out for these tabs spaces issues. There's more than just tabs and spaces, I just keep picking on it, right? Static analysis, we use that so the reviewer doesn't have to look, oh yes, you're passing a string instead of an int there, when it should be a whatever. So you don't have to look for those things. And CI pipelines are also a bit like having a living, breathing thing, right? Your requirements for your project will change over time. You will add more requirements, is usually the case. But As things mutate, so should your pipeline, because your pipeline should be testing as many possible facets of your requirements as possible. But you should also allow removal of checks if they're not helpful, right? If a particular CS rule isn't working for you, maybe you like long lines because you all have wide monitors or whatever, agree as a team, hopefully unanimously, and say, okay, that's fine for us, so make that exception. But also, I mean, less so with coding standards issues, but definitely stuff like static analysis tools, the things that they will pick you up on in that tool, you need to think, why is that picking me up on this? And understand the trade-off. If you want to silence that particular issue, understand the trade-off you're being made. Tools often recommend things like best practices, or the commonly accepted way, or like everyone does that, it's fine. Or the right way, TM, if there is such a thing. But understand that every project is different, right? Every project is unique. And we all have our own specific requirements. And that's okay, right? So code reviews by a human is still really needed, I think. Not everything can be automated. For example, the reviewer should be looking for things like, is the change itself designed well? Does the change itself actually solve the problem that we have? Does the change have some kind of positive impact? You know, are we able to refactor something better later down the line, or as a direct result of this change? Are there issues that need to be addressed immediately, or deferred for a future Jira ticket? That's okay as well. Let's talk about it later, as long as it's fine to like merge or whatever. Do the tests, and obviously the most important thing I think is, do the tests cover the requirements? And I don't mean code coverage here. I mean, like, do the tests that we have actually say, okay, this feature is supposed to work this way, and the tests prove that, or at least to the best that we could do. So, importantly, we should be treating each other with respect when we do this, and remember, it's the code being analyzed, not the human. And that applies to both the reviewer and the reviewee, kind of both ways. Like, this is supposed to be a discussion, not like berating you for coding badly. So, that human aspect still has to persist, like having the human reviews. We can't automate absolutely everything in that regard. But when we do that part, we have to make sure that we're being respectful to each other, right? So, next steps for your pipeline. Anyone recognize these steps? Anyone? No? It's these are the Potemkin stairs in Odessa, Ukraine, which I had the fortune of being able to visit before Putin did his thing. So yes, next steps. Build matrices. Don't worry, no mathematics needed here. That's just a nice picture. So build matrices allow us to test the same stuff in different scenarios, right? Different OSs, Linux, Windows, OS X, and other OSs apply. Believe it or not, there are other ones. Different PHP versions, different framework versions, and so on. I mentioned I have a tool, like it has to be compatible with like Laravel 10, 9, 8, 7, whatever. I can't remember how lower version we go down to. I think it's 5.5. So I have a huge build matrix that tests against all sorts of different PHP versions, all sorts of different Laravel versions, all sorts of different Symfony versions, some other stuff I've forgotten. But it's using these build matrix, right? So it allows you to parameterize these things and use the same build steps, right? So quick example, we want to test this project against both PHP 8.1 and 8.2. So we specify a matrix in the YAML. GitLab has a very similar sort of thing. Don't worry about it, it's roughly the same, just different YAMLs. So we use the PHP version that we want to test against in the setup PHP step. And that's really all there is to it. So this particular example would generate 2 jobs that repeat the same steps for each PHP version we have. And so you can add more dimensions to the matrix as well. We can have PHP version and different PHP extensions, right? This particular example will generate 4 jobs. It will have 2 PHP versions and 2 combinations of PHP extensions. So we have PHP 8.1 with Intel, PHP 8.2 with Intel. We have PHP 8.1 without Intel and PHP 8.2 without Intel. So, build matrices. Next thing, secrets. Eventually, some kind of end-to-end test or some kind of test that you're running will need to connect to some service properly. It needs some kind of authentication, like an API key or something. Typically, you can specify these at different levels: the pipeline itself, the project, or the repository, whatever you want to call it, organization, groups, whatever. GitLab has so many ways of organizing this stuff. It's very flexible. And just for bonus info, you can actually define variables to use later on, so you can like dynamically define stuff. But yeah, we won't go too much into that. So let's say we have an integration test of some sorts that needs some API key for this service. So the test talks to that API. We need to specify the key using GitHub Action Secrets. You go into settings or whatever for your project, or GitLab variables. And you can inject that secret API key using that substitution, like the $ curly braces secrets dot whatever you're trying to do. In this example, the secret's being put into an environment variable. And the nice thing is GitHub Actions and GitLab pipelines and so on do quite a good job of masking this stuff. Like if you just do echo service API key, it will mask it. But it's not foolproof, right? They provide these ways to prevent exposure. But let's say, for example, you write the API key to a config file, and then that config file you've exported as an artifact. Well, that API key is going to be in the artifacts. So there are ways of getting your API keys out. And it's for exactly that reason that secrets aren't typically available for, like, if you forked a repository on GitHub, because otherwise a third-party contributor could say, okay, email me that API key, email myself, and then run a build. They do other things nowadays, like you have to approve first-time contributor builds and things like that. So they take steps to try and prevent this, but it's not foolproof. Someone sufficiently devious enough could potentially find a way around it. So just be aware of that. So we have our basic pipeline, right? We want to add more stuff. And I can't really go into too much detail because, as I said earlier, every project is different. Every project has its own requirements, its own quirks, its own setup, and so on. So I'm just going to suggest some very common things that I've seen and tend to kind of lean towards in introducing in projects. Stuff like acceptance tests and end-to-end tests using tools like Behat, Codeception, end-to-end tests like Cypress and Selenium and so on. Those are great in CI, especially because they can take, if you're doing testing at the UI level, which isn't always the best way of doing things, but those kind of tests take a really long time. So we don't want to necessarily have to sit and wait for these to run on our own machines, because we're wasting our own time when we can make a machine do it for much less cost. Code quality and metrics. Stuff like mutation testing, code coverage, stats generation, if that means anything to you, linting API specs or API descriptions and so on. That's a nice one that I usually, especially working on API projects, obviously, I would be like, okay, let's make sure that the API description is correct every time we do a build so that we don't break it. Database related stuff as well. Maybe you want to do ORM schema validation. Maybe you want to test your migrations. A typical thing that I would start with for testing migrations is start from an empty database, run migrations up, and then run migrations back down again to destroy the database. And that will hopefully catch any basic errors in any of the migrations. And that runs every time, so you don't have to remember to run this all the time. And then there's kind of general admin tasks as well. For example, publishing documentation. Maybe you want to publish something to GitHub pages, GitLab pages, whatever, and ship some documentation. Maybe that's your API docs, or information about your code coverage, information about your SARM or PHP stan issues and things like that. Maybe you want to do some kind of chat ops integration, like when we've done a build, ping someone in a channel annoyingly every 5 minutes or something, whatever works for your team. And that's kind of what I'm saying, like it's really down to the team. And then of course there's custom checks for whatever you can possibly think of, because we have to remember this is just shell scripts, right? It's just writing shell scripts. Unless you're running in Windows, in which case it's maybe Bash, maybe PowerShell, depending on whether you're using WSL or whatever. Anyway. Some examples from real-world projects. We have scripts that check for memory leaks, right? This open source library I have, we wanted to make sure that we don't introduce any memory leaks when we run the stuff, because we had one and we're like, okay, let's make sure that doesn't happen again, because otherwise the customers will not be happy. So we have a test that measures the memory. We have another one that uses AWS CDK to generate a CloudFormation template, because the customer says, we only want CloudFormation, you will have no CDK. So we generate the CloudFormation template from CDK. And we commit the CloudFormation template, and that allows us to actually see the diff between that as well, which is kind of nice in reviews. You can actually see the impact that your changes in CDK have made to the CloudFormation template that will eventually get deployed. Breathe. We have other things like checking architectural decision records don't have conflicting IDs, like if there was a botched merge conflict or something, that we don't have two ADRs with the same numbers. We have another script that compares the template of a configuration file, which we use as a semaphore to say, oh, the configuration format has changed, and so on. The only limit is your imagination, right? Now, there are other ways of making this easier, like if you're already using a load of tools but you don't have CI, something like Laminus CI matrix action and Laminus continuous integration action. Those will basically analyze what config files you have and like what PHP versions your project support, and it will generate you a load of CI pipelines, which is kind of cool. I think I've not actually, I did try and use it on a project, but it was a project with weird requirements, so I didn't actually manage to finish using it. But this stuff, as the name suggests, is used heavily on Laminus projects, just to make rolling out all these CI pipelines a little bit easier. And so that may help you as well. It's not like flashy names or anything, it tells you exactly what it does. It generates a CI matrix, and so on. So deployment pipelines, well, deployment. What is deployment? It's just running a load of shell scripts, right? Really, at the end of the day, that's really what it is. So this can be automated too, as you may have guessed. Anything from like a simple FTP or FTP or SSH, whatever, deployment, that's fine. People still use FTP to deploy. Pipeline that invokes CloudFormation templates and so on, that's fine. It works. You can put this stuff into your build pipelines, and you can then start doing funky things, like if you make a merge request, you can deploy a review deployment, so you can see what that will look like and interact with it directly. And when the PR or MR gets closed, you tear down that environment, so then it sort of frees up those resources and so on. So that's kind of useful. And build artifacts. Most CI systems will allow you to generate build artifacts, that is files or directories that are, or values that are extracted from your workspace. Let's say, for example, you build a PHP extension. So you might want to take the .so file, put it in an artifact, and then later when you release, you grab that .so file and attach it to the release notes in GitHub, for example. Or if maybe you want to extract log files from your execution so that you can see what the log files contained when your tests failed or passed even, If you run something like Cypress, you can attach screenshots and videos and so on to the build, so you can see those and actually get those videos, and that's useful build artifacts that come out of your builds. And I mentioned earlier, you can use typically build artifacts as a mechanism for sharing data between steps as well. And then you can actually do that in child pipelines if you use GitLab, and it all gets very confusing. So the goal here is to automate all the things, or well, most of it, all of the checks. So all of the things that you want to add to the pipeline are all the otherwise checks that you're doing manually, right? We want to try and eliminate all of that manual step as much as possible. So the effect is that you increase your confidence to ship over time, right? The more you do that, the more you see that green build, the more you add to that CI pipeline that provides value, at least, that will help you to become confident that when you make a change, you're not going to break things. We don't want to break things, right? And the fact that it's done automatically, you don't have to think about it, it's even better, right? And now, go forth and write more tests and hire Rove, of course. Thank you very much, and don't forget to join the Rove Discord server. Thank you very much.
Thank you, James. Amazing talk. Any questions? Remember, we've got elephant, right?
Oh,
Did
yes.
I hear it right? Yeah, all right.
Someone down here.
So, any questions? I don't know, what is the criteria? Like, anyone who asks a question?
Well, the first question gets the Heroku goodie bag, or no, the Rove.
Well, any question or relevant question.
Relevant question. That's a good qualifier. Thank you.
There you go. I've got one hand up. Hope I didn't miss anyone else.
Hi, thanks for your talk. Do you use shared workflows or shared pipelines?
Yeah, I mean, GitHub Actions are, or, you know, you can provide, or you can consume GitHub Actions. They are shared by nature, right? Yeah, absolutely. We have things actually made by Kieran here. There's a pipeline that he devised which basically forward ports through branches that we, you know, if we make a patch on an older branch, it will automatically merge that up to the latest branch and things like that. So yeah, absolutely, yeah. Cool. It's whatever works for your situation. Yeah. Go on, another question. You. I have a Heroku goodie bag which does contain an elephant.
Can we ask a question about your singing career? Anyone? Come on. Everyone is as shocked as I was.
Oh, there's a question here.
Thank you.
There you go.
So, have you ever had performance problems with GitHub Actions? And did you look for ways to improve them?
Not as such with GitHub Actions, beyond the fact that that project that I mentioned that supports like Laravel, Symfony and all that, it takes quite a while. It takes about 20 minutes for all the builds to run, because I think the matrix generates like 350 odd jobs. So, I mean, I wouldn't say that's a performance bottleneck as such. It's just, it's testing a huge amount of stuff. So I just let it do its thing. But no, the only performance issues I've had really was with GitLab pipelines in a corporate environment, and that was due to the way the stuff was configured, and that was out of our hands really. So, but you know, if the resources for your pipelines are being provided by the company you work for, rather than like some GitHub Actions or whatever, which is just limitless resources, right? You know, if you are being provided resources by your company, then you should try and be mindful about resources that it's taking up, like too much memory and too much CPU and things like that, especially if it's shared workers amongst all of the various teams you have. But yeah, we're mindful of that for sure, and we try and be nice citizens and not just like consume all of the resources as such. So. Cool. I have no more goodies to give away.
You've got an online question, sorry.
Yeah,
okay.
I have another question. So, talking about build good testing habits, It's all about personal team discipline. What's the best way to create these habits?
It's I don't know, it's a mindset you have to get into, right? You have to say like, okay, I've had enough of just like half-baked solutions all the time and trying to just ship things out. And with a lot of like working environments, you don't necessarily have that luxury. You know, if you're under pressure constantly to ship things, you're going to cut these corners. And so it's got to be, you've got to try and be disciplined about it, try and fit things in to your schedule. Like, factor that into estimates as well. Like, if you're giving an estimate and say, oh, this is going to take me 3 days to deliver, and another day to test, well, you've shot yourself in the foot, because your customers are going to say, okay, we'll have it without tests, thank you. Because they don't want to pay extra or think things to take longer. So, you know, we, or certainly I, don't provide testing or, you know, producing CI to prove that things work as an additional line item. It's not like an optional thing. That is the service I deliver, right? And that's just it. So it's a lot of discipline, I guess.
Thank you.
Anyone else? Okay, well, thank you very much, James.
Thank you. Thank you, everyone. Cheers.